So for our first exponent rules, we have the product rules. And so the first one above is the same base rule. So with this one, as you can see, the same base is A. And so for that one, you add the exponents together. And the second one we have on the bottom is the same exponent. So for that one, you multiply the bases and you raise the product to the same exponent, which the same exponent in this case is n. And then we have examples of the product rule. So we have the same base example here. And since the base is the same, you add the exponents and the base stays the same. So here you have the base being x and the exponents being 6, 12, and 1. So you add those together to equal 19. So you have x raised to the 19th power. And then here we have another example, and this one is the same exponent example. So since the exponents are the same, the bases are multiplied and then raised to the common exponent. So here you have 3 raised to the second power, and then 4 raised to the second power as well. So you would multiply 3 times 4, which equals 12, and you would raise that all to 2, and then that ends up being 12 times 12, which equals 144. So then we have the quotient rules. So for this one above, we have the same base rule. For this one, you subtract the bottom exponent from the top exponent. So in this case, the same base is a, and then the top exponent is n, and the bottom is m. So you would have a raised to n minus m. And then on the bottom, you have the same exponent rule. In this one, you distribute the exponent to both the numerator and the denominator. As you can see, you divide a by b, and then you raise that whole to n. So for the quotient rule example, we have a same base example here. So since the bases are the same, you subtract the exponents and simplify. So you have 2 raised to the 5th divided by 2 raised to the 3rd, and it ends up being 2 raised to 5 minus 3, which is 2 raised to 2, and that equals 4. So we have a same exponent rule here. So since the exponents are the same, the exponent applies to the whole fraction. So you simplify the fraction first or distribute the exponent first. So here you have 4 raised to 3 divided by 2 raised to 3. So you have, and as you can see, they're both raised to the 3rd power. So you have 4 divided by 2, and then that's all raised to the 3rd, which ends up being 2 raised to 3, which is equal to 8. And then so we have other power rules here. So the first is the power rule, and for that one you multiply the powers together, but if there are no parentheses, you solve the exponent first. So the first one you can see that there are parentheses, so it ends up being b raised to n times m, and then for the bottom one you can see that there's no parentheses there, so it's you would first raise n to m, like you would apply the m exponent to n, and then you would raise b to then to what you just found. And then, so for the next one is the fractional exponent, so that's the 3rd one down. And in that one, the numerator is the power and the denominator is the root. And then the bottom one is the negative exponents. So for those ones, it becomes the reciprocal and the exponent turns positive. So for this one, it's b raised to negative n. So it's 1 divided by b raised to n. So for the power rules example, we have where you multiply the exponents together and raise the base to that power. So it's 2 raised to 3 times 2, which is equal to 2 raised to the 6, which equals 64. And then for the bottom, you have to solve the exponent first and raise the base to that power and then find the answer. So for that one, you would be 2 times, raised to 3 times 2, so that equals 2 raised to 9, sorry. And then that ends up equaling 512. So, and then for the fractional exponent examples, for the next one, we have the one where the power 6, which is 6 in this case, becomes the numerator, and the root, which is 2, becomes the denominator of the exponent fraction. So it ends up equaling 2 raised to 3, which is equal to 8. And then for the negative exponent example, we have that it becomes the reciprocal. So basically 2 goes to the denominator, and the negative exponent, negative 3, which was negative 3, becomes positive. So it ends up being so 2 raised to negative 3 is 1 over 2 raised to 3, which equals 0.125. And then for simplifying a ratio, we have an example here. So ratios can have many variables. So you use the exponent rules to combine 2 or more fractions or ratios and simplify those. So we have an example here, which is just on the last slide. So for this one, how do you solve it? Basically, you simplify each base by applying the exponent rule. So for the first one, you're going to apply the quotient rule to x. So you would subtract the exponents of x, which is 2 minus 1, which equals 1, so x remains raised to 1 in the numerator. And then you also have quotient rule for y, so you subtract the exponents of y. So it's 1 minus 4, which equals -3. So since y is raised to the -3rd power, y remains raised to 3 in the denominator. So next you multiply the two together, and then you add the exponent rules, apply the exponent rules to simplify further. So you use the product rule for x, so you add the exponents of x, which are 1 and 2, that equals 3, so then x is raised to the 3rd power. And then you use the quotient rule for y, so you subtract the exponents of y, which are 3 minus 3, so that equals 0, and so y cancels out. So here's another example. We have y squared times y over 2. So for this one, use the product rule. So since the basis of y, which are y, of the exponents are the same, so you add the exponents together. So that ends up equaling y cubed over 2, because it'd be y raised to 1, 2 plus 1, and then divide that whole thing by 2. So another example here, which is 4x y raised to the 4 divided by x times y raised to 3. So for this one, use the quotient rule to subtract the exponents of y from each other. So on the top, you have 4, and then on the bottom you have 3, so that ends up being 1. And then so y would be raised to 1. And then for the quotient, use the quotient rule for x. So the x's cancel out because each are to the power of 1. So on the top you can see it's x raised to 1. On the bottom it's x raised to 1. So 1 minus 1 equals 0. So you get a final answer of 4y. So in summary, we went over the objectives, which includes the exponent rules and introduction to multivariable products and quotients. And then you have exponent rules, which include the product, quotient, and additional other rules. And then you have the simplifying ratios, which use the exponent rules to simplify ratios of different variables. And then we did some examples that included practice problems to practice the rules and get used to seeing them. And that concludes the presentation.